Good morning, good afternoon, and good evening, everyone, and welcome to today's webinar. Today, we will be talking about unleashing the power of AI edge processing with our partners SolidRun and Hailo. Today's speakers will include John Nettleton, Chief Software Architect at SolidRun, DC Smalley, who's General Manager of North America at Hailo, and then we have John Felipe, who's Partners and Ecosystems Manager for Machine Learning, AI, and Computer Vision at NXP. And with that, I'll go ahead and hand the microphone over to our first presenter.
Hi, I'm John Nettleton, the Chief Architect at SolidRun, and thanks for joining us today to hear about the collaborative effort that we've taken on with NXP and Hailo. We have a very exciting webinar today where we're going to be talking about unleashing the power of accelerated edge AI. We're going to talk about a new product that SolidRun has in collaboration with these two partners, and then I'm going to pass the mic over to them so they can give you specifics about their parts of the product and how this all works together. I'd like to thank DC Smalley from Hailo and his team, who will be talking about their product. Really excellent high-end AI inferencing hardware and SDK. And then John Felipe from NXP is going to talk about the i.MX 8M Plus and all its features and benefits. I'm going to be going over the product as a whole, talk about the specifics, what SolidRun has done to bring all these products together and why it's so important. I'm going to show you a few demos, talk about some of the use cases where we've already seen interest in the product, and then I'll pass things over to DC, who can talk about the Hailo SDK, the product and capabilities, and then to John. So what is the collaborative approach for Edge AI? Well, what it is bringing a bunch of features together and products on the market, and not just slapping them together and rolling them out the door, but actually working with the partners and bringing all the pieces together so they work uniformly and seamlessly, which allows our customers to just get up and running as quick and as possible. We attack this because we had the i.MX 8M Plus SOM, but more and more our customers needed more features. They needed more compute. Inferencing models are getting bigger and more advanced. And so that's why we brought in Hailo into the mix, and we've reworked our platform so we can better support all the features our customers needed without compromising at all. What we did is we start with the i.MX 8M Plus, which is a very capable SOM and very featureful. The main features that are very important to this specific product are the dual ISPs that are on board, and it also has its own MPU, which is 2.2 tera operations per second. This is excellent for basic machine learning, vision processing, doing motion detection or basic object detection on smaller models. But if our customers need more, then we have the Hailo 8 accelerator now in this product, and that gives over 26 tera operations per second, its own dedicated memory. So for high-speed processing and more advanced models, like actual facial recognition and other features, or running multiple models in parallel, we have that feature set now. And SolidRun ourselves, we've redesigned our board in order to accommodate all this hardware without cutting any features or cost. It's an industrial rated, ready to deploy SBC, and when you combine all this together, you get a product that has dual camera ISPs. We support Basler cameras out of the box. It can process an inference at 28.5 tera operations per second. All of this takes less than 10 watts of power. 10 watts is really the peak. And all of this together is in a 100 by 70 millimeter platform, which is very impressive. And here it is. For any of our customers who are familiar with our products, this is a very standard form factor. This is our Hummingbird platform. But what we've done is change both the SOM as well as the carrier in order to bring out all, without compromising any features, add the additional functionality that we've needed, which is the improved inferencing from Hailo. And so what we do is on the SOM, we have dual PHYs now, and that has freed up the PCIe lanes that we can brought out to the NVMe M.2 slot, which is where we can mount the Hailo 8 accelerator. We still have two MIPI CSI connectors, one on the SOM, one on the carrier, USB, dual Ethernet, one of them PoE enabled. So this entire board can be powered by a single Ethernet cable, including the AI accelerator and cameras, which is very installation friendly. On the SOM itself, we have allowed it to be scaled up to 8 gigabytes of RAM and 64 gigabytes of eMMC. Obviously, I've already talked about the two MIPI cameras. We also have the ability to have dual HDMI screens if that's needed in the product, or you just want to use it for testing or demo. Again, PoE, the SOM itself has 802.11 AC Wi-Fi and Bluetooth BTLE5 for your standard internet and wireless connectivity. We also have a mini PCIe slot on the bottom that is wired to USB 3, which means that you can have LTE 5G. We have a SIM card holder mounted on the board and ready to go. As with all our products, we consider this a deployment ready solution, and all the pieces that we've brought together can all be industrial grade, and we provide a embedded longevity of 10 plus years. What we feel is a very distinguishing factor of this product and this collaboration is the integration of the BSPs. We're not giving you an SBC, telling you to talk to Hailo. You go get Hailo's software or Basler's drivers, and you're spending time integrating this yourself, running into any sort of conflicts within the BSP, getting support from us. We've worked with them. We've brought all the pieces together into our BSP, so everything works out of the box. If you order the board, you'll get it. You'll get a software image, and you can immediately start. You can connect a camera. You can immediately start running demos, start looking into how you're going to port your product and your model to run on the hardware that we've made available. Now we're going to look at some demos here. This is a pretty standard demo that you're going to see with doing vision processing. For us, this is just showcasing the overall, all the products working together and how it will work out of the box. This is the Humming board. This is using the Hailo 8 as the inferencing engine, running Hailo model from Hailo Zoo, and being captured by the i.MX 8M Plus camera. You can see the ISP is doing a great job. Everything looks good. Even something as small as the small cars on a mobile phone screen are being picked up by the Hailo 8 and identified properly. But you see even the i.MX 8M Pluses, and that's what this is, MPU, is able to do scene detection. This is a 1080p video, and it's able to keep up at around 30 to 40 frames per second doing basic object detection. This is very important as for power reasons, since you don't need to use all the power available for the Hailo 8. Even though it is a low power one, it's over half the power budget of the entire device, but the capabilities are worth it. And then you move up to the next level, which is the Hailo 8, where you see it's not only locked in and picking up all the devices, it's actually picking up the license plates and doing OCR, turning that into actual data that can be collected and tracked. And so what do you use this for? Well, a lot of our early customers are falling into two general cases, although these aren't all of them. The first one being security and surveillance. And really what this is providing is you can collect data about things going on without having to be there. So say for a virtual chaperone in a large car park, since you're covering a lot of area, the machine learning models can pick up, there's a group of people here and there's an individual walking and it's night. It can pick up that scene and alert security ahead of time. Hey, this is going on. So if the security's out on patrol, they can swing by and just be there as a presence before anything bad happens, and catching things ahead of time, making sure people are in the right place. With virtual patrol, this is a very similar idea, but really what we're talking about is, um, we all know the movie scenes or the TV scenes where there's the big wall of monitors and the security guy in the room and he's nodding off, and then they're missing all the um, uh, bad guy stuff going on. Well, not anymore with a system like this, because really what you have is on the camera. It never sleeps, at least our hardware never sleeps. And you can have the NPU on the i.MX 8M Plus doing just basic object detection or event notification. Oh, hey, this is going on. And then passing it up to the Hailo 8 to see if it's actually something that's worth alerting. And then you're going to be able to bring that to the forefront of security, even notify maybe somebody who's out and about. You can also do things where if multiple devices are positioned in different locations, pass that information and tracking so you know the direction of the person or the event throughout the building that you're monitoring. Very useful things that are basically just taking away the human error. Oh, additionally, we have our defense use cases, and this is really where the battery part and the power savings is of utmost importance, because obviously a lot of these are battery operated devices, and the more battery that you're using for your inferencing and detection is going to be less distance that can be patrolled and less power and time that the unit can be out doing its work. And so what you get is you can have a camera connected to the NPU. Nothing interesting is happening on the object detection. You're using as little battery as possible. But as soon as something of interest happens and it triggers the NPU's model, or it just sees something that it doesn't know about, it can then start passing that video feed over to the Hailo 8 to run even more advanced models and understand in a split second, is this something that matches what the device is looking for, and send out early notifications or move accordingly. And the same with a drone detection system. The i.MX 8M Plus also has an M7 core, which can run a real-time operating system. Say that's connected to a gimbal. You can have a nice wide field of view camera that the i.MX 8M Plus is watching, and then if it sees something in the distance, basically you can use a gimbal and a long lens camera and start to get a tracking, very close up video of the object in the distance, pass that to the Hailo 8, and run whatever models are necessary. Another thing that's becoming more and more common are ensemble inferencing, and that's basically when you use different models trained slightly differently on different hardware on the same image in order to get a higher accuracy. Basically, if they both agree, then you are pretty sure that the drone is a drone. But if one disagrees or the other, maybe you need to train better. You can use the data that's collected for that, or you can accommodate it, and maybe you don't react so quickly on it because there is less accuracy. If any of this interests you and the product interests you, I would please ask you to head over to shop.solid-run.com. You can also go to any of our authorized distributors, Aero, Future Electronics, or DigiKey, and they'll be able to provide this product for you. If you have any questions, feel free to contact us at order@solid-run.com. I will now pass the webinar over to the Hailo team and DC, and take it away.
So my name's DC Smalley. I'm the GM of North America at Hailo. And so we'll talk about the AI chip enabling this SolidRun system with NXP to run complex AI tasks at very, very low power. So for those not already familiar with Hailo, we are a silicon company, started in 2017, focused on the highest power efficient AI chips for at the edge inferencing. To date, we have a portfolio of products, two main families. And for today's discussion, we're really going to focus on the accelerator family, which we have branded H8, which has been in mass production across many customers and applications. And we have a roadmap to bring additional products to the edge over the next couple of years. We are continuing to push the state of the art in terms of TOPS per watt and cost efficiency for inferencing complicated AI functions and pipelines at the edge. And as John mentioned, while we are a chip company, really the core of Hailo began with software in mind. Software is certainly key to make the practical use and optimization of AI user-friendly and productizable. So it has been critical to our success, to our customer success, that we offer a mature software environment, deployment tools to be able to quickly and easily work with AI models and get a system running inferencing very quickly. If you can move one slide ahead. Okay, so now into the technology a bit. So what is it about the Hailo technology that makes it such a powerful solution in these applications and these use cases? So we have the H8 and the H8L, both operate as co-processors, adding essentially a massive amount of AI compute when paired with ARM or x86 processors, where we are processor agnostic. That is our accelerator technology. So Hailo, we handle the AI tasks. You offload those to our chip, things like object detection, classification, segmentation. And through that, we enable customers to create complex applications consisting of multiple models. So things like license plate recognition, drone identification tracking, anomaly detection. These are all applications built from many models, in some cases together, that need to run efficiently. And so to do that requires, really data center class AI performance. And Hailo, we offer products ranging in TOPS from 13 on up to 208 TOPS. For discussion today, we'll focus on the 13 and 26 TOPS solutions. Also really relevant, these edge applications usually require very low power consumption, as John's alluded to, and also effective heat dissipation. And that's where our hardware architecture really shines. There's no external DRAM required for the Hailo device itself. The chip architecture was built from the ground up with efficiency in mind. And so AI workloads typically run in the 2.5 watt range on the H8 and even lower on the 8L, which we'll talk a bit about. Also, key to supporting an extremely wide scope of applications is software. And as I mentioned, our software suite, it lets you bring your own models to work with or work with hundreds of commonly available models that you'll find in our extensive model zoo. We'll share links to that model zoo. It's also readily available on our website. And what's also key is that includes both convolutional models, but also some of the newer transformer models that are supported on Hailo. Our solutions, another key is they're both scalable and flexible. So for example, with Hailo, you can run multiple streams through a single H8, as in the examples John's referred to support deployments from one to many streams. You can also run multiple models. So we enable the creation of complex applications out of, sort of a pipeline of AI models. And then you're also able to combine multiple Hailo chips and to be able to scale the AI compute linearly from 26 TOPS at the H8 on up to 208 TOPS and beyond. We have customers that are working at those levels. And further to that, we have both industrial and auto grade parts in the market today. Advance the slide if you could, please. I'll move on to the two key products that I will focus on today, which pair very well with the SolidRun and NXP Hummingbird. So first on the left is our H8, the core line of devices, which has been in mass production with hundreds of customers bringing 26 TOPS of AI compute to an x86 or ARM system. We have customers using chip down, as you can see at the sort of the top level, the COB. But most actually choose the simplicity, the M.2 form factor, which you'll see below. And that's the architecture you'll find in the Hummingbird. We do support multiple keying configurations. So we will have an M.2 that's configured to fit most compute systems, including a mini PCIe that we're not showing here. And then on the right, so Hailo has recently expanded our accelerator lineup to support an even wider range of applications with the H8L. It's at 13 tops, so exactly half of what you'll find with the H8. It's an amazing device for less challenging AI workloads at an even lower price point and actually an even lower power consumption range, typically under 2 watts, again, running full inferencing. So, as I talk about flexibility, if you're uncertain about your current or future AI workloads, you can develop based on either H8 or H8L using the exact same form factor, M.2, the exact same SDK, which we will talk a bit more about, and change direction late in your development. Or you can offer sort of a tiered solution to your customers based on the specifics of their AI workloads. All right, if we can move one slide ahead. So performance. So moving beyond the spec of tops, tera operations per second, how does Hailo actually compare in practice to some current solutions you'll find that exist on the edge today? So one, Hailo is very open about our software and our performance. So the Model Explorer I mentioned previously, we're listing our actual performance, not theoretical target performance for these models, on 100+ models on our website, which you can check out. And I've shown a few examples here. On the left, or on this slide, comparing to some common NVIDIA SOMs, running a standard ResNet benchmark used to compare. And you can see here on the leftmost side, the H8 beats these more costly options in raw performance, inferencing performance, up to say 2.5 times in this example. But as you look on the left-hand side, as viewed from power efficiency, tops per watt, the delta becomes even more pronounced, a 7 to 8x improvement in that category, which is really key for a key metric for edge inferencing, right? Tops per watt. You can move ahead one more slide. I'll refer to the 8L. So we also have a comparison on our entry-level H8L, and again, similar concept. You can see on the left, the raw performance is unmatched by these other TPU solutions you might be familiar with. And then as you look at cost efficiency, power efficiency, further emphasizes the gap really that we see between Hailo and competition in accelerating edge applications. So to kind of conclude here, and then I'll move on to Victor. If you like to compare our performance, as I mentioned, you can check us out online. We're very open with our performance. You can come to us and ask for specific comparisons, system level or otherwise, and we'll help you there. Or you can get an M.2 and have a system up and running your specific models very quickly and easily to see for yourself. The typical customer experience is to have models ported and running within a very short amount of time, often within the same day. So you can actually see your models running your workloads in real time. And now I'll move on to Victor Cheng, who's one of our US-based FAEs, and he'll talk a little bit about what's under the hood of our hardware and the power and the simplicity of our software environment.
I'm Victor Cheng, Senior Field Application Engineer at Hailo. I will talk more about the underlying technology and the software that enable fast development time and inferencing of your AI application on Hailo. Hailo's claim to fame is its unique data flow architecture, which is specifically designed to process neural network graphs efficiently. Each layer of the neural network is mapped onto a cluster of control, memory, and computation elements. This distributed nature of computation allows each layer to run in parallel with the others, and the use of smaller elements leads to lower power consumption. Selecting smaller neural networks or reducing the target frame per second also save power, as fewer hardware elements are used. Besides, the elements are chosen such that the memory elements are closer to the computation elements, reducing processing time. The partitioning of the neural network graph into this physical resource graph is abstracted by Hailo software, enabling the running of a variety of neural network models, ranging from convolutional neural networks to the latest transformer models. The Hailo AI software suite is a robust and scalable set of development tools and runtime libraries. It simplifies the process of compiling deep learning models, implementing AI applications in production settings, and deploying them across various form factors using the Hailo 8 processor. For developers designing their own custom model, the suite includes a model build environment featuring a dataflow compiler that transforms deep learning models into executable formats for the Hailo hardware. This compiler supports ONNX, PyTorch, and TensorFlow formats and effectively maps deep learning models to Hailo's neural network core resources, which are the control, memory, and computation elements. For developers seeking open source models, they will find the Hailo Model Zoo, which houses over 100 cutting-edge pre-trained models for tasks like object detection, classification, segmentation, pose estimation, multiple object tracking, and face detection and recognition. It also includes the latest transformer-based models, such as vision transformers and CLIP. Additionally, the suite offers Hailo RT, a lightweight, production-grade runtime library with low-level C and C++ and Python APIs, as well as a driver for managing and communicating with the Hailo device over the PCI interface. It is compatible with Windows and Linux operating systems, including Ubuntu and Yocto, and supports x86 and ARM processors. Hailo RT is easy to integrate and requires minimal CPU power and memory on mid-range ARM-based processors during inferencing on Hailo 8. To further expedite time to market, Hailo provides Tapas, a comprehensive collection of full application examples, pipeline elements, and pre-trained AI tasks. These examples, based on GStreamer framework, showcase Hailo system integration for specific use cases on both x86 and ARM embedded systems, and can be utilized for evaluations, reference code, and demonstrations. Previous slide. For developers designing their own custom model, the Hailo Dataflow Compiler is an automated software toolset that compiles and optimizes trained models for Hailo's executable format. Its key features include an efficient quantization scheme, which balances performance and accuracy, allowing for flexible trade-off. An automated resource allocation for meeting desired user requirements that are frame per second, latency, and power consumption. An accurate offline profiler that provides precise measurements of FPS, power, and latency. We also provide a bit-exact emulator on the PC to ensure expected accuracy. The compiler supports multiple Hailo devices and is forward compatible. These features are designed to streamline the deployment of AI models on Hailo hardware, ensuring optimal performance and ease of use. For developers seeking open source models, the Hailo Model Zoo is an open source Hailo Model Zoo is an open source repository offering pre-trained models in TensorFlow and i.MX formats tailored for high-performance deep learning applications. The Hailo Model Zoo automates the conversion of these models to Hailo format to enable quick replication of Hailo device performance for both evaluation and development purposes. These models, optimized for high accuracy and public datasets, can be retrained with updated dataset for enhanced performance. To help you pick an open source model, the Hailo Model Explorer is an interactive tool available on Hailo website that lets you browse and compare hundreds of models from our model zoo. These models were tested on Hailo 8 and Hailo 8L platforms. You can filter and sort the models by task and name, set criteria such as FPS and accuracy to find the best fit for your needs. The Model Explorer shows you detailed information for each model, such as number of parameters, input resolution, frame rate, original and quantized accuracy on Hailo. With our Model Explorer, you can access our rich collection of models, including both CNN and transformer-based models, and discover new ones that suit your project. This is it for the Hailo part. I will hand over now the presentation to John Philippe of NXP. Thank you.
Hi, my name is John Philippe, and I manage the partners and ecosystem around AI, ML, and computer vision for the Secure Connected Edge division of NXP, which includes the i.MX portfolio. I'd like to give a quick thanks to John, DC, and Victor for the great presentation so far. For those of you who thought this webinar was somehow related to the 8th installment of the Hailo video game series, well, I apologize for the disappointment. Okay, so we've learned about the compact and industrial Hummingbird 8P Edge AI platform, and we've also learned about the incredible power of the Hailo 8 accelerator. I'd like to now explain how unique features of the i.MX 8M Plus combine to make this solution greater than the sum of its parts. The i.MX 8M Plus is an incredibly powerful and feature-rich SoC. I don't have time to touch on every single feature of the part, let alone all the items on this slide, but I do want to point out a few things which I'll cover in more detail today. The 4 ARM Cortex-A53 CPUs provide the bulk of the computing, and the Cortex-M7 provides the ability to run various real-time OSs for system wake-up and monitoring functions. There is both a 3D and 2D GPU, a VPU, a DSP, and a dedicated NPU, all of which provide a powerful heterogeneous compute platform. There are 2 MIPI CSI2 ports, along with 2 integrated image signal processors. Together, this provides a nice platform for cost-effective machine vision applications. The integrated NPU is 2.3 TOPS and capable of running a variety of neural network models across various modalities, such as imaging, voice, and time-varying data. And there are 2 1 gigabit Ethernet ports, one of which supports time-sensitive networking standards. Let me provide a brief overview of an image signal processor, or ISP. An ISP takes the raw output from an image sensor and converts it into an aesthetically pleasing image. The image sensor's raw output is an unusable black and white image. The image undergoes a series of functions such as demosaicing, which converts the black and white raw image into a color image, followed by things like white balancing, lens shading correction, black level correction, color correction, and many more, resulting in a nice color image. The dark image on the left is an original raw output from an image sensor, and the right image on the right is the post-processed version after going through the ISP on the 8M Plus. An integrated ISP provides several significant advantages, including cost savings. An ISP embedded in the applications processor enables a lower cost vision system since a discrete ISP is not needed. Another great feature is longer product availability. The NXP longevity program guarantees that the i.MX 8M Plus will be in production for 15 years. And I'll also note the support for high-definition cameras. Many newer and higher-resolution image sensors don't include an integrated ISP, so you'll either need to find a discrete ISP, if you can, or an SoC that includes one. This is a list of our current partners that can enable our customers to develop imaging systems using the i.MX 8M Plus ISP. These partners have all been vetted by our systems engineering team and have customers using the i.MX 8M Plus ISP. These partners offer differing capabilities and expertise, from full ODM services to camera module design and build to just camera tuning, as well as a global reach, because we understand that it's nice to have partners located close to your offices. The i.MX 8M Plus's integrated NPU has a scalable 8 and 16-bit integer multiply accumulate engine for tensor operations. Its specialized neural network hardware supports activation and pooling, and it supports a variety of neural network topologies, such as CNNs like MobileNet, YOLO, etc., and different types of RNNs like GRU and LSTM. The 8M Plus is a very power-efficient platform for various embedded computing needs. Here are some power numbers while running a variety of common benchmarks to exercise various system features. I like to point out the max power of 2.2 watts running the 3D Mobile Mark GPU benchmark, and the deep sleep power of only 19.5 milliwatts. Because of the low-power nature of this compute platform, we have customers deploying the 8M Plus in solar-powered applications, which greatly reduces installation costs and opens up more potential deployment locations since people don't need to run a fixed power line. Moving on to our software enablement, we have the Real-Time Edge software, which is an evolved version of Open Industrial Linux for real-time systems. The key technology components include real-time system, heterogeneous multi-core framework, heterogeneous multi-SoC framework, real-time networking, and protocols. For different schedule latency requirements, Real-Time System provides preempt RT Linux, native RTOS on Cortex-A core and Cortex-M core, RTOS on Cortex-A core with Jailhouse, bare metal framework, and a flexible combination of different cores running preempt RT Linux and RTOS or bare metal to meet different real-time requirements for different use cases. The Real-Time Edge software supports a flexible asymmetric multiprocessing system to run various OS and bare metal combinations. For example, all 4 A cores could run on preempt RT Linux, while the Cortex-M7 core runs in RTOS. Or one or more A cores could run preempt RT Linux, while the other A cores run one or more bare metal or RTOS instances, and the Cortex-M7 could run in RTOS. That's just 2 examples. The only limit to the combinations is your imagination. For machine learning, NXP offers the EIQ toolkit. We aim to enable users of all backgrounds and expertise levels to develop or port their machine learning applications onto the family of NXP microcontroller and application processors. All of this baseline enablement is offered with no additional licenses or fees. There are a few additional integrated advanced solutions and services from NXP partners, which are a part of the EIQ marketplace. But specific to the EIQ toolkit, you can work with your own data within the EIQ environment to build and curate your datasets for training. You can select, optimize, and validate models, then review the performance. Or you can bring your own trained model from training frameworks such as TensorFlow, PyTorch, or the ONNX exchange format, and leverage different inference engines to target the end device and deploy. We also realize that ML inference is part of the solution, and we support our users with EIQ pipelines enabling sensor data input, giving intelligent results for vision, audio, and anomaly detection applications. We also provide application software packs with full code that can be leveraged towards product development. Our i.MX SoCs make use of GStreamer, which is a framework for creating streaming media applications. For those unfamiliar with GStreamer, think of it as a framework to easily construct a media pipeline. For example, one might want to pipe the video being generated by a camera to a display, but convert the video from RGB 888 to RGB 565, and also changed the resolution from 4K to standard HD. GStreamer plugins make it easy to do this in one line of code, which can be run at the command line or integrated into an application. NNStreamer provides a set of GStreamer plugins so developers may apply neural networks and attach related frameworks including ROS, IIO, flat buffers, and protocol buffers, and manipulate tensor data streams in GStreamer pipelines easily and execute such pipelines efficiently. Both GStreamer and NNStreamer are fully supported and integrated in our BSP releases. This is a flowchart showing an object detection pipeline built using NNStreamer and GStreamer. Notice the plugins to take advantage of the dedicated hardware accelerators such as the NPU and the GPU. The source code for this example and others can be found in NXP's NNStreamer GitHub repository. There's a link to that repo at the end of this deck. So let me bring it all together with an example system design. Imagine you've got an assembly line that requires some kind of quality control inspection. You can start with the SolidRun Hummingbird AP and add a camera or two. Those cameras could be an off-the-shelf module from one of our many partners or a custom-developed solution taking advantage of the integrated ISP. Next, you can either build or port some type of vision model for your intended use case with the help of the EIQ toolkit. So now imagine parts moving down the assembly line, and you want this quality control system to make a quick pass-fail decision using the 8M Plus NPU. But then you also want to do a deep dive on the flawed parts, and so you then use the power of the Hailo 8 accelerator for a larger, more advanced object detection model. Once you've finished your analysis, you'll want some kind of robotic manipulator to physically separate or sort the bad parts from the good. Well, then you can use real-time edge to send traffic over a time-sensitive network to the robot arm. This ensures real-time operation and no delays due to background network traffic. And all of this can run 24/7 in harsh industrial conditions. And in the rare case that the system breaks in 10 years and you need a replacement, well, don't worry, we'll still be building them. There is demo code available showing the real-time networking and CAN bus control available at nxp.com. Here's some links to learn more about the various hardware and software enablement from NXP that I just covered. I'd like to again thank SolidRun and Hailo for this joint webinar, and thanks to everyone who took some time to watch this presentation.